Hillel, over to you.
Thank you. Can everybody hear? Somebody in the back, wave if you can hear me. Perfect. Almost the back. Cool. So first of all, I am cognizant that I am what stands between you guys and video games and beer. And so I will try to be timely and leave room for questions and make sure we're ready to drink something as quickly as possible. And also, I appreciate you guys sticking around and staying for this. Hopefully it'll be worth it. I also want to take the opportunity to say thank you to the organizers, Phil, Joe, Rick, everybody who's involved. I get to be last, so I get to say it was really a fantastic day. I really enjoyed a lot of the lectures, and hopefully this one will be okay too. So thank you guys. What I want to do is, okay, so the agenda. So some housekeeping. I'll just talk about myself a little bit really quickly because that's my most interesting slide. And then we'll talk about serverless. I know everybody's dying for one more what is serverless pitch. So I'm gonna do it. I know, because nobody got one today. And then I'll try to use that to be more interesting and talk about what serverless security is and what it isn't and why it is and why it's different, et cetera. I'll try to sort of paint a recipe for serverless security and then talk a little bit about how developers and DevOps people have to find themselves in that story as well, and how the whole picture has to look, and then a couple of resources at the end and some wrap up and some questions. Hopefully all that fits into beer time. So I am Hillel Solow. I am the CTO of a company called Protego Labs. We are a startup that focuses on serverless application security. So our customers are people building applications on the public cloud using serverless technologies, primarily things like Lambda and S3 and Kinesis and so on and so forth. Before that, I was in Cisco for many years and in a company for NDS for countless years before that. I can't remember what I did before that, but it was a long time ago. So let's talk about what serverless is and what it isn't. My favorite cliche is that the cloud is a new operating system. I hope there's nobody from AWS here. They hate when I say that because they have a whole antitrust thing they're worried about. But I think when we think about cloud native and serverless as part of cloud native, really what we're thinking about is, and this couldn't be any more different than the previous talk, which was great, but is not about, how do we take software that we wrote to run in all sorts of places and get it working in our AWS account, but really how do we build software for the cloud? And we think of the cloud as an operating system. Like any other operating system, we think about what are the resources that operating system provides us with, what are the abstractions that operating system provides us with, and how do we build software that takes most advantage of that operating system. And of course, like any good operating system vendor, which AWS is not, I didn't say that, but if they were, their goal is to lock you in, yes. Their goal is to make you benefit and enjoy and the wonderful services their platform provides you in a way that you're going to want to stay forever and never leave. Now, this is my favorite, simplest cliche way to explain what serverless is and then sort of miss some of the revolution. I built this way, way back when. I think I stole it from somebody else and then they stole it back from me and I stole it back from them. But all it says is we are giving more and more control over to the cloud provider. We are happily ceding control to the cloud provider. We are primarily, as consumers of the cloud, building applications on the cloud, we are building application code. We use APIs. We configure that code and deploy it. That's what we own. Everything else we're giving over to the cloud provider. They're dealing with health and scaling and monitoring and patching and operating systems and all that. And that's great. That's a net win. When we talk about security, that'll be a net win. It's good. Amazon's going to do a better job than almost anybody in this room at patching their runtimes. It also means when we start talking about security later on and we think about where we're getting security from and how we achieve security in an application, we're going to have to focus on those things that we own because that's where we can play. That's our domain. So it's going to be code, it's going to be API, it's going to be configuration. Now, just to make sure that we all disagree on what serverless means, I think serverless means at least 3 different things, okay? And I think people tend to sometimes confuse these different concepts and sometimes argue about whether something is serverless or not. Is DynamoDB serverless or not? Is S3 serverless? Can I do serverless on-prem? And any other question you might ask with the word serverless in it. I think sometimes it boils down to these 3 different types of revolutions. So there's what I call serverless infrastructure, and that's our relationship with the cloud provider, right? Do I pay for a machine per month, or am I paying per invocation? Do I pay to store a file, or do I pay for a machine that stores the file? So that relationship, I think, is about the infrastructure. It's how we relate to the infrastructure, it's how we pay for the infrastructure, it's how we think about it. It's the, buying a car versus taking an Uber kind of paradigm shift, right? And that has very little to do with the software. It has more to do with our relationship with the cloud provider, how we want to be billed, how they want to bill us, things like that. Serverless architecture is how we build software. And if you've been to enough talks today, and I hope you have, what you're seeing is, Yan Shui showing you a slide with 4,000 little dots on it and stuff like that. You're seeing that serverless architectures tend to look different than non-serverless architectures, mostly because of the stateless and ephemeral nature of serverless compute, but there are other reasons. And so when we look at serverless applications, they tend to not look the same as non-serverless applications, for better and for worse. They tend to be very difficult to debug. They tend to be very hard to observe, but there are differences in how they look, and that's serverless architecture. And then there's serverless operations. How do I run software? And very often that's where you hear people say to you, oh, you know why I love serverless? Not because I hate debugging, because that's terrible. Not because I can't figure out what's going on, but because once it works, it just freaking works. You know, I put it in the cloud, it scales, it heals, so magic. And of course that's not entirely true, but that's the sentiment and that's the feeling that you get. And that's about how you can minimize your DevOps and how you can really move to a much faster velocity of feature deployment and things like that. And so that's serverless operations. Then when you have questions like, well, I'm doing serverless on-prem. So that's not really serverless infrastructure per se, but it's certainly a serverless architecture and operation. So maybe you are serverless. I don't know if you need two-thirds or what, but I think those three things are separate. Let's talk a little bit about how security gets affected by this. So but before I get into the 10 minutes I'll talk about what changes, I'll say it boils down to two things. I'll call them risks and opportunities, but let me be very clear. I'm a little bit atypical of security companies. I'm not here to tell anybody, oh my God, you built a serverless application, that's terrible for security. I don't think that's true. I don't believe that. I don't think it serves anybody any good purpose. I think that there are two things that happen when you move to a serverless application. One is there are things that we as security people have always been doing, particularly in application security, things that we've always worried about, that just look different in a serverless world. A WAF is not a great security tool in a serverless world where input can come from all sorts of triggers and directions and third-party APIs that a WAF can't necessarily see. A RASP solution, a runtime application self-protection, is an agent that we install on an operating system. We don't own the operating system, so where are we going to put that? So some of those things are just things that we've always been doing in application security that we've always been worrying about, but the way that we need to worry about them or how they manifest might be different. And then the other side, which I like to talk more about, is the opportunities, because that's something that I focus on a lot, is there's some opportunities that come out of the move to serverless that I think are unintended consequences, certainly from the software developer's perspective. But as security people, we see those and we think, oh, that's a great opportunity. We can do something with that for security because you've been kind enough to move to serverless. So if I boil it down to the changes and the differences, and these are goods and bads and they're kind of mixed together, topology is very strong and very clear. So I put a little picture on the side so you can know what I mean when I say topology. The topology of the application has changed quite a bit in serverless. I talked about the fact that there are lots of small pieces rather than a few large pieces. The notion of a perimeter, which personally I think is a very poor paradigm for security in any cloud application. The notion that all the bad guys are in one place and all the good guys are in another place and they're all going to come through the WAF and I'm going to see them all. I think that's kind of naive. I think that we need to consider all the places that our resources interact in the cloud and figure out what we trust and what we don't trust. But certainly in a serverless application, the idea that there's this really nice perimeter around our application and everything bad is on the outside of it is just not a realistic approach. And so we need to think about other ways to protect our application. The event triggers, if you play with Lambda, who here has not written a Lambda function or played with one? Let's get the negative question. One. Come on, somebody else here. Nobody wandered in by mistake? All right, I believe you. So if you've played with Lambda functions, you know there are 15 or, I don't know, maybe Amazon just released another one today when I was looking, 16 trigger types that you can deploy your functions with. Some of those are your classic, API gateway type triggers, which are the way your application always was built. But some of those are S3 triggers and Kinesis and AWS IoT and AppSync or whoever else, whatever else could trigger your Lambda function. So it definitely bears reasoning. What are the ways my application could be triggered, and how can a bad person do something? What happens to attacks in a serverless world? What do we have to think about in terms of bad people? What are they doing? And hint, spoiler is, bad people mostly are doing the same things. They care about the same things, they want the same things, they're after the same goals, and probably mostly at first they're not even aware that you've moved from a container-based application to a serverless-based application. They're just not, it's not something that's on their radar. But there are a couple things that we are seeing at least people talking about and changing, and I think one of them is really important. I call them the Groundhog Day attacks, which is one of my favorite movies, and that's where rather than try to attack your system, find some way in, make some lateral move, download some files, create a user on a machine, sit there for 6 months, harvest credit card numbers or something like that, right? Serverless functions, they run in these little containers or non-containers depending on which cloud provider you talk to, but they don't run for that long and they don't last that long and there's no notion of long-term persistence in that kind of attack. So what we see more is people saying, well, I don't have to live in your application for 6 months. I just have to find a way to send some spurious request to it, make it give me 50 credit card numbers back from the database, and then do that 10,000 or 100,000, a million times. And you know what? It'll all work because it's serverless. Your application will just scale to handle it, no problem. So that kind of attack, which is more sort of a rinse and repeat repetitive attack, is something we see more. And that means when you look for attacks, you very often have to look for attacks that manifest over time in iterations and things like that. Velocity is really important, and velocity is a double-edged sword. So I said one of the reasons people come to serverless or stick with serverless is the feature velocity, the ability to deploy more value to the customer faster in shorter iterations, and that's really valuable. And whether or not you want that out of your serverless application, once you go serverless, I will tell you, you can't go away from that. Your customers very quickly learn to expect things to be fixed in hours and not days, new features to be deployed in a day or two, not in a week or two. So that velocity is something that everybody wants out of serverless. It also means that it can be very challenging to manually configure anything. Anytime someone says to you something that has to do with, oh, let me update a file, let me change something, let me just go review something and change the WAF configuration or something, you realize, okay, this is not going to work in a cloud-native world. Like, I'm not going to be able to keep, as a security team, I won't be able to keep up, okay? But velocity also means that remediation can happen really quickly. So we can demand remediation quickly. We can say to a developer or for a security person, hey, wait a minute, that file is no good. Here's a new version that's better. Switch it. And don't tell me it's going to take you 2 weeks because it took you 3 hours to do the whole feature. It should take you 10 minutes to redeploy. And then 4 hours in the pipeline. I know how that works. The upsides and the big pluses and the real wins are in serverless are granularity and visibility. What I mean by that is as follows. Granularity for debugging and observability is a nightmare. And anyone who does a serverless application will tell you, yeah, I used to have 10 container types I was worried about. Now I have 150 functions, and I have no sense of whether everything's working well or not, and how do I figure out where the problems are. And that's all challenging, and there are companies in that space and tools in that space and lots of talks in that space, which is not me. But I will say as a security person, that granularity is my friend. So one key example of this is IAM roles. So you all know that there are IAM roles for every function, and for every Lambda function I can associate a role. Very often people will associate a single role with all their functions. Please don't, but we'll get to that in a second. I can associate an IAM role with each function. I could make that IAM role very minimal. I can go for least privilege in a way I never could before. Because each of these functions is very small, single purpose, going to do one thing. So we'll get into that. So that granularity, the ability to apply security policy like IAM roles and defense policy and other application policy at a very narrow, fine-grained level is going to be very powerful for us in terms of security. And the other thing that's really our friend is visibility. So one of the things you see in cloud applications classically is my example of this always is there's a company out there, there are probably two, whose entire product line is, I will scan your EC2 instances and tell you what they are. That's a database, that's a Spark analytics engine, that's a front end running Nginx, et cetera. Because to the security person, these are just boxes and I have no idea what they are. And so applying security policy, making decision making, should that thing talk to that thing when you don't know what that thing is or that thing is really challenging. But in serverless, by and large, for the most part, databases are DynamoDB or RDS or Athena, and analytics pipelines are EMR or Spark or Kinesis or something like that. And so we have very well labeled named resources. We know what they are, and we look at things like, hey, should that function be able to talk to that resource? That's a question that's easier to answer in a serverless role where we have better visibility. I like to say the bone structure of the application is much more visible in a serverless or cloud native application than it was in a classic sort of monolithic, I've got a bunch of machines, go figure out what they are, security person. And maybe that highlights, before I get into how we try to solve this problem, one of the key issues that I find with security is that in a classic organization of sufficient size to care about security, there is usually a very big chasm between security people and developers. And the way, if you talk to security people, here's something, they're going to say something like this. They'll be a little bit more politically correct, but not much. They'll say something like, developers are idiots, and they're always going to be idiots. And they're going to write stupid bugs and crazy mistakes, and we can't mitigate that. But what we're going to do is we are going to lock them in a zoo. We're going to put a WAF over here and a DB firewall over here. We're going to run some agent on the operating system over here. We are just going to abstract away their access to the real world and try to mitigate all of their stupidity from there, right? Now, you talk to developers, they say, security people have no concept of what's going on. They think they can defend their application from the outside, but they don't know what the application does. They have no sense of what it does, what it's supposed to be doing. They have no visibility. They never ask us any questions. They just go lock things off. And then we have to send them an email, please open this port up or this service up. And what do? They open it because they don't know better, right? So that chasm is huge and is a real problem. And it's a real problem in serverless. And I think part of what we're going to look for in a solution is how do we obviously, peace and harmony in the world and all that, but how do we, bridge that gap? And one of the things you'll see is really challenging is security people have their heart in the right place, but they don't necessarily have the visibility and the information and the skill set to make decisions that are based on what developers are doing. And so as developers, we have to help them. We have to bridge that gap with them. We have to, extend an olive branch or something and say, okay, what can we do? But then, and I'll get back to this again later, the thing that we have to be very careful not to do, because I've seen this in organizations, to say, oh, serverless, I get it. Developers, you're now responsible for security. Problem solved, right? Except let's be realistic, developers are not going to do security. That's just not their bailiwick. That's not their area of operation. They're responsible for building functionality, testing, getting out to a customer. Security is responsible for making sure that nothing bad happens to it, but it's the partnership. All right. So in terms of the why me, depending on who you are and what you care about, right? As I said, security people cannot absolve themselves from the problem, so they still are the owners of this problem. They're still responsible. The developers are responsible or part of the solution because more and more they own configuration. If you told a cloud security architect 5 years ago that his developers were going to craft IAM roles for production instances, he would have laughed at you. And if you tell a developer today in a production, in a production application built on serverless, hey, you can't build IAM roles that the production function is going to run with, and I've seen this literally in a company, they'll quit because they're moving at the speed that they can't wait for security to reconfigure IAM roles every 2 days. So a lot of the security controls have shifted hands from security people to developers. And so as a developer, that's great. I get to run with scissors, but now I have the scissors, right? So I need to do something about that. And DevOps very often is because they're the bridge between the people who care and the people who are doing, and they're the ones who very often own the real estate for automation. So when we talk a little bit about automation and how we automate some of these things, DevOps very often are the people who have the ability, if they're focused on the right things, to help these two other groups get together and solve the problem. So here's a recipe. Focus on 3 things, and how, why, when, afterwards. But one is optimize your security posture. So security posture is everything to do with, I call it passive defense. It's everything to do with how have I deployed things? Have I deployed things in a way that minimizes my risk? Okay? So think of that as like the doors and windows in your house, right? You're not buying a high-end managed security system with laser beams and machine guns if you don't have a front door, right? You're first going to focus on, well, I got to get a door in my house, I got to put some windows in. Now it's hard for people to break in. Now I can focus on an alarm system to see if somebody tried to, jimmy my lock or something, right? I think my metaphor broke down somewhere. So security posture is about what we call good hygiene. It's about IAM roles, permissions, vulnerable third-party components, risky code, people leaving keys around inside the code, all the things that happen that create risk in your application and that are easily avoidable if we're just doing things right, looking for things in the right place. And so in terms of the why serverless, so why do I care about hygiene more here than ever before? So one is the fine-grained architecture is going to create much more value out of hygiene, right? Because since I can craft policy and hygiene around each of those resources individually, every bucket, every table, every function individually, I get to really reap the benefits of carving away all the things that don't need to be there and just deploying things that have to, that matter more. And also more visibility. My ability to drive a lot of that hygiene automatically based on what's going on is really powerful in a world where serverless. One more thing I'll say about why hygiene is serverless is serverless tends to create sprawl. So if you watch what happens with teams who build serverless applications, they very quickly deploy test stacks in US West 2 and try something out in EU East 1, and they leave these things out there, and they no problem. There's no billing review at the end of the month that goes, hey, what's that EC2 instance that says test machine Hillel? Oh, yeah, we can take that down, right? That doesn't happen because we're not paying for Lambda functions that nobody invokes. But they are part of our attack surface. There's an API gateway somewhere. I guarantee, by the way, I've seen, I would say 70 to 80% of organizations we work with, when you first plug in our product, and this is not a plug for the product, when you first plug it in, and they go, we have 40 functions. And you plug in, they scan, and they have thousands of functions sometimes. Because first of all, they have all the old versions. The versioning thing in Lambda is ridiculous, but you've got all these old versions that are callable, and then you've got all these test stacks that people put up in all sorts of places, usually in regions you're not using, so you don't accidentally mix them up with production. They're all part of your attack surface. If somebody finds that URL for that API gateway endpoint, Bob's your uncle. You can go after that. That's probably some old version, no testing, no code, no error handling, right? So those things are really important. So that's another reason why hygiene is really important in serverless. In terms of the how, automation is king here. And that's where really DevOps is really important because really the only place to do good automation for security is in the DevOps pipeline. Asking developers to do it manually just doesn't happen. Security people come in too late. Security people come in afterwards, they see things in the cloud, they go, oh my God, I can't believe that's running in the cloud already. But DevOps is the place where you can go, wait, if I can get policy in here, if I can say, wait, nothing goes through this pipeline that is too risky or too crazy or too unchecked, then that's really powerful. And the automation is king because, as I said earlier, most of these things, they just don't scale manually. If you have 5 functions, by all means, do a manual code review of their, the permissions and the libraries and the third-party components you're using every time you deploy them. That's okay, you can manage that. But if you have 50 functions, it's just not scalable. So you've got to find tools that automate. In terms of the challenge, I mean, if you've ever written a Lambda function, you've done this, or if you haven't, then I want to meet you and hire you. You've said, okay, I've got this code that does S3 get object. It doesn't work without permissions. Everybody knows that. I'm going to go to the IAM role for the function. I'm going to add S3 wildcard, S3 resource wildcard, because it works. And by the way, because some of the Amazon documentation says this. Okay, and I love you, Amazon, but some of your documentation still says this. Now, if you're a little bit better, you're not an idiot, I care about security, you'll do something like this. Now, why do you wildcard the action? Because it's often almost impossible. S3 is actually not as bad as some of the other services. Sometimes it's really almost impossible to figure out what permission you need for an API call. It's not a one-to-one mapping, it's not the same word, it's not the same name exactly, you've got to figure it out. Screw it, I'm putting a wildcard in. I promise I'm going to come back later and fix it, but nobody ever does. And then here's what's probably close to least privilege. You could do better, but this is pretty much least privilege, right? I only do get object, so let's just do get object. What's the difference? The difference is, if this code is this code, it's fine, great. But if there's some vulnerability somewhere in this function, some way for an attacker to get inside, he can now do anything to any of my buckets, or at least anything to that bucket, my bucket over there. Whereas in the least privilege one, yeah, he can read things out of that bucket, but he can't list the files in the bucket, he can't delete the bucket, et cetera. So that's better. The opportunity, and this is where I get back to the granularity, and here comes the world's simplest slide, I promise, is this, okay? So here you have two versions of an application. Pardon the use of Microsoft icons. Just imagine it's DynamoDB and S3. Here you've got a container-based application on the, I'm terrible at this, left side? Left side, perfect. And the equivalent serverless function-based application on the right side. Okay? And all I've done in this abstraction is I've taken those functions that are packaged together in containers, your front end, your back end, your analytics pipeline, whatever it is, and I've just freed them from the constraints of their single role per container world. Okay? So now imagine we've got our attacker, he's red, he wants our pot of gold, it's yellow. Okay? All he needs to do is find a function in one of these two bottom containers that has a vulnerability in it, because each of those containers has a role which allows them to access that resource that has the pot of gold. Right? Because something in those containers uses that. So he's now got 9 ways to try to find my gold. Okay? Taking the same application, no extra security, nobody looked for the bugs or found them, they're all still there. But now if I look at the attacker in the serverless application, he really only has 2 ways to get into the application, to get to the gold. Because there are only 2 functions within those 9 that really need that resource. It's just that they were living in a container with other functions. So we've now sort of shrunk our attack surface from 9 functions to 2 functions, right? So that sort of illustrates, hopefully in a really simple way, why the shift to serverless unintentionally created an opportunity for security that didn't exist before, but also creates the challenge of leveraging that opportunity. How do you decide about 4,800 IAM role permissions for each function every time a function gets deployed? And again, the answer is probably you want to automate that. Okay, the second piece of the recipe is discover what you need to care about. And so here the challenge really is, we've used machines as the proxy for a lot of things over the years, right? So we don't know if the application is healthy or not, but we can look at whether the machine is healthy or not. We use that as a reasonable approximation. So we'll look at like CPU usage or disk size or things like that in a machine and say, okay, that machine's running at 100% CPU, let's drop that container, pull up a new one, because there's something wrong with it, right? So now we don't know what's wrong with the application or if it is even the application inside or something else inside, but we do know that the machine's misbehaving, and a machine's a reasonable abstraction for health. We use machines for other forms of monitoring. We use machines to monitor security. We look at machines and how they're behaving and say, hey, that machine shouldn't be talking to that machine, let's block it. Because we don't have a really good sense of what's happening inside the machine. And machines are a reasonable abstraction, except someone pulled them out from under our rug, pulled the rug out from under us with them. We don't have those machines anymore. And now we're struggling very often to know what we care about. So we're looking at a serverless application with its 120 functions, generating 30 or 40 billion lines of logs every month, and trying to decide, okay, which are the important resources here? What events matter in the logs? What do I care about, right? And that's hard and easy. So why do I say it's easy? Why do I say in some ways it's easier? Because the profiling part, the baselining part of a serverless application is much easier. The notion of, hey, is that thing that just happened supposed to happen or not, is an easier question to answer in a serverless application per event than it was in the past. Why? Because serverless functions most of them all the time, do the same things every time. They're small, single-purpose, single-flow functions. They handle one request to add an item to the shopping cart or to check out from the store or to get my images or whatever it is. They handle that one flow. And if you call them 1,000,000 times, they're probably going to do the same thing more or less those 1,000,000 times. And so when we look at events and we go, wait a minute, that function, let's say we're looking at CloudTrail or something, that function just accessed that database. It never did before. Okay, that's a big red flag. It's not a container where there could be code that runs once a year that I haven't seen. It could be, but it's very unlikely. It's much more likely that's a red flag, and I need to be looking at that. So the baselining part is easier, and that's our friend here. If we look at the data right, and we use it right, and we abstract it correctly, and we learn from it, we can use that. The challenge, of course, is, again, there's a tremendous amount of data. We need to do this baselining right. We need to learn from it what we care about, and then bring that. So a lot of the products that you need to look for, not just for APM monitoring and performance, but also for security, are things that can help you with visibility into, okay, what do I actually care about? And then the third thing is defending workloads from within. So this goes to the perimeter problem, okay? The perimeter problem says it's really challenging to draw the circle around your application. So maybe if I do it this way, I think I have a picture, right? So if you think about your classic application, you draw your perimeter in a certain way around the application. You think about that one way you expect your attacker to come in, and you go, okay, that's my perimeter. I'm going to load up a massively expensive but really good WAF there or something. I'm going to have 3 security engineers configuring that thing all day long, making sure that they know what a SQL injection looks like and whether this parameter should be a number or a string, and whether or not it's okay for there to be a single quote in this field, okay? And that stuff is going to keep me safe. And that, your mileage will vary on that. Your kilometerage will vary. I'm going to go where you guys are in the shift. You're going to get so much out of a WAF. It's not the best paradigm for security, but it works reasonably well. It's probably better than the alternative, which is pretty much nothing. But then when you move to a serverless application, you're suddenly trying to draw the perimeter, and you're trying to think, well, what are all the ways into my application? So you go, okay, I've got API gateway triggers, but I got a few others. I have an email coming through SNS that triggers my function, so I got to think about those headers and emails. You know, what could those do? I actually call out from my function into third-party services like Twilio or Zapier or something like that, or Slack's API. And so I have to think about data coming back from those things, because those things could contain vulnerabilities. So I have to start thinking about all these parts of my perimeter. And the way that we try to focus on this, and I think is really important, is to try to pull the security back from the perimeter to the resources as much as you can. Okay, so as much as you can say, it's not like I'm going to say everything inside my perimeter is healthy. No, I'm going to say every single function needs to be looking at everything coming in and out of it and deciding, does that make sense or not? Okay, now, the good news is when you look at a function, you ask the question, hey, is this thing okay or not? It's a bit easier to answer that question than it was in the past because, again, functions do the same thing more or less all the time, and so we can focus on following those patterns, using those patterns to know what's good and what's bad. But again, the challenge is we need to do that no matter what the input is, no matter what the trigger type is, no matter where it's coming from, no matter whether the data came in from the front door or a side door, we have to make sure that we're protecting it. And so the way that we focus on it, I think, is really valuable, and we've seen a lot of players in this space doing, is bringing security from the perimeter or the operating system up into the function in some sort of transparent type of layer or module that you can put into the function that will just sort of magically, hopefully, give you security. Okay. So before I get to the questions, I wanted to point out 3 things. One is, the only plug, which is not for me, is for the URL for the resources page on our website. It's got a lot of really useful resources. If you're interested in serverless security, some of those are videos we've created, blog posts, whatever. Some of them are things we curated from other places. It's really got a tremendous amount of stuff there, so I think it's a good place to start. 2 things that are linked to there but are worth pointing out that we've done with OWASP. One is a serverless top 10 that we're working on. So that's really sort of just interpreting the OWASP top 10, which is sort of the Bible for web application attacks. What do I have to worry about? Do I have to worry about code injection? Do I have to worry about misconfigured APIs, things like that? Reinterpreting that for serverless. What does it look like in serverless? What does it mean? It's a good document if you're looking for something that explains to you, well, what does an attack look like on serverless? How's that going to manifest? And then how could I possibly defend myself? That's a good document. We did a lot of work on that, but there are lots of other contributors as well in OWASP. And then if you want to go a step further, there's a project called DVSA, stands for Damn Vulnerable Serverless Application. And the idea is to give you an example application that is vulnerable to lots of attacks with documentation about what those attacks are and some scripts to run them. So you can try, you can learn, you can evaluate security tools, you can get a sense of, wait, what does a SQL injection look like or what does a MongoDB NoSQL injection look like in a serverless function? So those resources are really useful, I think, and if you use them and you've got involved, think about getting involved, particularly with the open source ones. If you're at the point where you go, I have an idea for another attack, there's a great place to contribute that kind of stuff and really get involved. Okay. That was it. I think I'm pretty on time for beer. Questions? A couple questions?
Very impressive timing.
I can just speak as fast as I have to.
Yeah. You do speak fast.
Yes.
But clear.
That's by the way, half speed.
Yes. Okay. Questions?
I answered it all. It's amazing.
Have you?
Apparently. Or they just really want to drink.
There's one.
Oh, there's a person there.
You talked about CloudTrail, and watching events in CloudTrail to see what the outliers were? Have you got any more details on that? How do you spot what the outliers are, or how do you determine what's different in the Lambda function?
Yes, so CloudTrail, for those who don't know, is the ability to monitor API calls in the AWS system, typically in CloudWatch, so you can get a CloudWatch log with the various events that have happened. Caveat is that it doesn't cover everything in the AWS ecosystem, so there's some disparity with what you can see there. The simple version of that is, if there are things you know you don't expect to happen, you can set up rules for that. You can set up a CloudWatch alarm that'll tell you, hey, somebody just added a user, or a Lambda function just did access something, and things like that. That will obviously not go very far. So what you really need is you need something where you can actually tell it, hey, figure out what's going on here, and baseline everything that's okay, and then give me alerts. There are some tools out there, either in the security space or in the monitoring space, that will do some of that for you. It's all very primitive today in serverless, because the biggest challenge is not just, is that thing okay, but is that whole flow okay? And that requires not just looking for baselining and then anomalies, but doing it across an entire flow. So, okay, every time that happens, and suddenly somebody managed to make that happen, that's what I want to spot. I don't know of any products that are there yet today. Certainly ours is not there yet today, but that's probably the holy grail there.
Hey, great talk. I've come across lately, building serverless applications, you still get these requirements to virus scan files and stuff. So where do you think traditional virus scanning solutions sit in a serverless world?
Yeah, first of all, they don't. And it's a great example of where, very often in the security world, the best thing we know how to do is take whatever we knew how to do yesterday and copy and paste it, right? And then in some cases, we'll try to look for the analogs. So we'll say, okay, well, we don't want a virus scan because that doesn't make sense. But the equivalent might be having something that scans your GitHub repository before the code makes it to the cloud to make sure that everything in there is original and correct, and you're not using third-party vulnerable components. So there are equivalencies, but an actual virus scanner has nowhere to run, has no persistence to run. So yeah, so I think it's a good example where you actually, and this is something we spend a lot of time on in serverless security, is doing one of two things. Either just trying to reimagine what is the equivalent of X in the serverless world, and very often it's something that's like X or similar to X, or completely different than X but provides the same value. And then the other thing we try to think is, and we don't always get to do this, but we try, is to say, actually, why do we need X? Why did we need X? And that's not to say that endpoint security doesn't have its place, but why did we need X? And is that the right thing to think about? Or if we go to serverless, is the value really in focusing on other areas? And sometimes I think that's really more important. But you'll see, if you look at requirements, you will absolutely see that. You'll see, virus scanning, and you'll see, we've got requirements. Some of them we do, by the way, so I'm guilty of this. We have a feature where we will encrypt data that a Lambda function stores in /temp. Okay, now /temp is a RAM disk, and honestly doesn't really need to be encrypted any more than the things that Lambda function keeps in memory need to be encrypted. But if you look at compliance regimes, they say things like PCI, they say things like data at rest needs to be encrypted. And as a customer, you can do one of two things. You can try to explain to the auditor why this isn't really data at rest, it's in memory, it doesn't count, or you could turn on the data encryption thing, which doesn't make a lot of sense, doesn't really make you more secure, but makes everybody happier. So you get a lot of that as well. It's a good question. But don't quote me. It's not recorded, right? Last one?
Hi, thanks for the great talk. I was just wondering, in a serverless world, especially with developers now having more leeway when it comes to defining roles, for example, have you found any new challenges when it comes to mitigating, for example, intentional or unintentional internal malicious actors? For example, petty, well, you get the point.
Yeah.
Or, intentional activity aside, for example, credential leakage and so forth.
Yeah. Yeah.
So
yeah, I mean, it's very often hard to distinguish between the intentional and unintentional in a lot of these spaces. It is a big concern, obviously. It's a concern everywhere, but it's certainly a big concern when a lot of your developers have access to cloud accounts. They might be production accounts sometimes, maybe they're not, but they're still out there, right? They're still in the world. And so even the unintentional damage a developer can do today is typically much higher, right? I can deploy something into a test account. That's a real AWS account callable by the rest of the world. And that function, yeah, I just put some hard-coded keys in there to some service and I left them there. And then I push that code into GitHub and I don't know who has access to that and things like that. So that's definitely an issue. I do think the intentional malicious part is really critical. I don't think it's well dealt with yet today. The main thing people are doing, and I think it's worth focusing on, is really, and this is a little bit further out, but focusing on IAM not just for workloads, but really trying to focus on IAM and permission boundaries and understanding how can I craft regimes where there's a really clear limit to what everybody can do. And so that's not going to solve all your problems, but it will at least create a situation where you know, okay, production accounts are production accounts. Most people can't get to those. You need two-factor authentication to access those. That's easy. You know, who can publish code to GitHub? Who can deploy code to this staging account? What types of code? You know, developers can publish perhaps Lambda functions, but maybe you don't need to give them permissions as an admin to publish everything. Maybe they can't create other resources like S3 buckets, things like that. So there's some work you can do in trying to carve out. You know, the biggest challenge people often have is my pipeline's got to run as admin because it's got to, you know, create all these resources. It doesn't have to run as admin. But it does take a lot of work to figure what permissions your pipeline does absolutely need to get the job done and still carve away all the rest of the permissions that are crazy. So it doesn't fully answer your question. I think it's still a big challenge, but there's some work being done.
Any
Here?
more?
All right. I'll call it a win.
All done.
Thank you very much.